Hello guys, I welcome you all to my YouTube channel. In today's video tutorial, we're going to learn about linear regression. So linear regression is a machine learning algorithm, also a supervised learning algorithm, means we are given a training data as well as the label data. So what that mean is regression. So suppose this is our training data, x1, x2, x3. This is x1, this is x1, x2, x3 like this, right? And this is feature 1, feature 2, feature 3, x2, x3, x4, right? So corresponding to every x point, so this is one x point, we have a label data. And also it is a continuous data because it's a linear regression, it's a regression problem. So anything could be that point. And these are the feature points. Suppose if we take a very simple example for students scoring marks in the exam, that would depends on how much time they are studying. Suppose here's something like this. This is the total time spent, right? And this is GPA they scored. So if I spend 2 hours per day, then I'm scoring 5 GPA. If I'm spending 4 hours a day, then I'm 7. If 6 hours a day, then 8. If I'm spending 9 hours a day, then I'm scoring 9 GPA. If 10 hours a day, then 9.5 GPA, something like that. So it's a kind of linear regression that depends only on one feature. If suppose there is one thing also like uh, um, the time, the sleep parameter can be also a thing. Like if I'm sleeping 3 hours a day, then definitely gonna affect on my GPA like that. So then this gonna be a problem of multivariate linear regression. But for now, we're gonna focus on only on one feature linear regression, right? Single feature linear regression. So if we draw a XY map of a linear regression, suppose these are the points here. Now we try to make a line. See, these are all the lines we try to make, and we try to identify a best fit line out of these lines. So definitely I can say that this particular line is a best fit line because it is minimizing the error. It is minimizing the error. So what is error here? So if I take an example for an error, so if it is a line, if it is a best fit line, suppose, right? So for this particular x point, my actual y value is this. This is my y actual, and my predicted value is this y predicted. Then this distance is my error because by this distance I went wrong. This point was my predicted value that was on the line, and this is my actual value. Then the difference between these values is my error for this particular point, and our total error is the difference between the error, addition of the error between all the points. So if we add all the absolute addition of all these error is called the total error. If we try to plot a diagram, then it would be something like this. The error would be something like this, right? This is not a differentiable function, right? So what we try to do is we try to square the error. So if I represent in the mathematical form, then the error would be y actual minus y predicted, right? Absolute of this is my actual error, but this particular function is not differentiable. So we try to take try to take a square of this. By this our error function would be something like this. So it's a good convex function that is differentiable also, and we have a local minima also. Now this we try to take differentiable of this function, so that by that we'll be achieving the local minima. So at whatever the x value, these are the x values, at whatever the x value we are achieving the minima. It means for that x value we are getting the less error, right? If you consider the line equation, that is y equals to mx plus c, let's consider the m and c to be theta 1 and theta 2, theta 1 and theta naught for say, right? So theta would be theta naught theta 1, right? We try to get the values of theta 1 and theta naught so that we get the best fit line, right? We try to get the values of theta so that we get the best fit line, and to get that the value of theta, we try to take the differentiation of this loss function and try to find the minima for that. So if I take the differential, so for the total error, it would be 1 by m, right? J would be 1 by m summation I equals to 0 to I equals to m, and it would be y actual minus y predicted whole square. Now we try to take the differentiable of this function, try to differentiate this function, will put equals to 0, and we'll try to get the value of x, because at that value of x we will be getting the minimum of that function, right? So we can directly conclude the differentiation using mathematical function, but we are not going to this approach. Why? Because this is okay for like this small uh, one feature problem, but if the feature increases, like say 100 features are there, then this is not a suitable answer. Then we try to go for another approach, that is gradient descent approach. Descent approach, right? So in that, what we do, we try to initialize x value randomly, suppose here, then we try to get to this minima step by step, right? No matter if it is initialized on the left side or right side, we try to descend the slope, and we try to get at the minima, and at that minima, that x value will be considered. If we put that x value in the loss function, then we'll be getting the loss function to be minimum. So this is the whole idea about this gradient descent approach, right? Now let's visualize what we have discussed earlier. Suppose I have the x points to be x is equals to, let's import numpy as np, and x is equals to np dot arrange to be 10 values, right? And y to be the equation something like this, x minus 4 and to the whole power 2, right? And x and y. So these are the values for x and y for now, right? Let's visualize these values. Import matplotlib pyplot spld plt.plot x comma y. Now here plt.show, right? As you can see, this is the convex function and the minima is somewhere right here. Now we'll be initializing x point to randomly, and we'll be just descending towards this minima, right? For that, let's see, suppose x to be uh, x initial to be 0, right? And let's do it something like that, plt dot plot x comma y, and here x to be 0 and learning rate to be 0.1. So what is learning rate here? If I show you, so learning rate is an equation, right? So it's a kind of equation for x equals to x minus learning rate of dx del x, right? So what is happening here is sorry, dj by dx. So what is here, this is the differentiation of loss function with respect to x. This is the differentiation of loss function with respect to s is multiplied by the learning rate and is updating to the x so that we are getting the new x. So the equation is x minus learning rate dj, that is loss function, is differentiated with respect to dx, right? So this is our loss function, and we'll be implementing this in a mathematical format here, that is for I in range. Suppose I'll be taking 100 steps, right? So it would be, let's that would be gradient to be, so if you see the gradient, it would be differentiation of this function, that would be 4 into x minus 4, 4 into x minus 4, right? And the new x value will be x minus learning rate multiplied by gradient, and we'll be printing x. Now you can see here we got value near by the final x value to be 4, right? And that is 4, definitely that is 4. We are getting the minimum to be here, right? Now let's see the gradient descent steps. For that, what I'll be taking is y, that is should I take it y? So let's take the error to be equals to this y function, that is here, right? And plt dot scatter x comma y. So let's run this program again, and y should be the same size, scatter, and this should be the e, right? So let's run, and here will not be plt dot show. Now as you can see, initially the x value is randomly initialized, and it is taking steps at a very slow learning rate, and initially the steps were larger, but as we approach towards the minima, the steps become very low, right? This is because this gradient will be larger initially, but after it will approaching towards the minima, it will become very minimum, right? So it is also multiplied with learning rate, and that is being updated to the x. So here we can see the learning rate, if larger, then this point may shift to that side, and will just jump on the left side to the right side, will take longer time to converge at this minima. So this was the whole understanding of gradient descent and linear regression. Now in the next video, we'll be implementing gradient descent for linear regression, right? This was the basic linear regression, right? So thank you so much for watching this video. Hope you enjoyed this video.